a few small topics which we'll finish first, and then perhaps we will look at a few questions. But anyway, these topics have to be finished, and they are kind of useful and important, but they are very small topics and in pieces. One of them is called storage classes, but I would like to show you using example what do you mean by storage classes and then do. Okay. We are talking of a wider topic called storage classes. Okay. Now, for the first one we'll understand is what is static. Now, this is a keyword which probably we'll introduce today, but it will come, you will see reference to that many times. In C itself, you will see two references, and when you come to Java or C++, you will see more references. Actually, the meaning of static in all these languages is not same, but is very similar. But you know what? Most people don't understand the similarity. They think this static is different, that static is different. It's only when you understand programming a little more deeper that you start seeing where are all these people similar. Initially, whatever we talk about will appear different in terms of the use of static. Over time, hopefully quickly, you will realize, oh, they are not so different, they are very similar to each other. Only thing is they appear differently in different contexts. Okay? So here is an example. Let's say I have a function which doesn't do anything, it doesn't return anything. So it's a void function. So I have a void function, and it takes maybe also no parameters. Okay? So it's a pretty simple signature of a function, call it myfunc, no parameters, no return type, and no parameters. Now I have one variable, int I equal to 0. I initialize it to 0. Then I say I equal to I plus 1. And then I say printf I equal to %d and I, and that's it. Okay, maybe put a backslash in. Now, this is my function. I think it's pretty easy to understand. It's one of the very trivial functions which probably you'll ever write. Void myfunc, no parameters. I create a local variable called int I equal to 0, I equal to I plus 1, and I say printf I equal to %d. Then imagine I have a main, okay, some main, okay. Then I say myfunc first time, okay. Then I say myfunc second time. Then again I am still amused, so I write it a third time. Now, can you tell me what will be the output? Myfunc, I get I equal to 1, 1 and 1. No surprises. I get the same answer. So what is all this? So this is very trivial and all that. Now, I am going to just write it, program it, and then I am going to introduce static. Then you are going to see what happens. What is the impact of static in these functions? Okay, first let's write it as it is, as you see it on the screen. Practice lab 53. So we're just writing whatever we just wrote on the screen again, just to re-emphasize. So we're creating a function void myfunc. And what does it do? It just creates a variable int I equal to 0 and says I equal to I plus 1, and then it says printf I equal to %d backslash n I. Okay, that's it. That's the function. Very simple, very trivial, very straightforward. Okay, then I write the main, and then I say I'm going to call this function thrice. once, twice, thrice. Yeah. So we are going to run it, okay? And we are going to see what we get. As expected, no surprises. We get I equal to 1, I equal to 1, I equal to 1 3 times. Correct? There's nothing. So what's happening here? What's happening is every time this function is called, a different I is getting created. Correct? And that I is starting off with a 0, then that I is getting incremented to 1, and then it is printed. Again I call it, again a new I is taking birth. So the I which is taking birth on line 4 is dying at line 7. All of you agree? The I which takes birth at line 4 is dying. Dying means going away, out of scope, at line 7. That is what happens with regular variables. Okay. Now, if you want the variables to persist from one function invocation to another function invocation, you don't want them to die, you need to allocate them in a different area of memory. Because the way these variables are allocated right now, these are called local variables. They are allocated on the stack. Some people call them local variables, some people call them automatic variables, some people call them scope variables. I have seen all these being used. I think a more common way of talking about them is local variables. So let's call them local variables. So here I is a local variable. And what can we say about the behavior of local variables? They are created at the point they are started, and they perish. They perish when the end of the block is executed. So they perish on line 7. They start at wherever they are created, whenever they are first defined or created. That is when they take birth, live the whole body of that block, and they perish. Correct? They perish at line 7. Now, if you want your I not to be of that variety, if you want your I to be of a variety where it persists, it stays, it remains, and doesn't perish at the end of the function, if you want your I to be created in that manner, why would you want your I to be created in that manner? Okay, for that, I think you have to go back to maths. Maths, have you heard of this definition called idempotent? What is idempotent? Something which doesn't have side effects. I mean, I don't know how you were taught what is the law of idempotency, but what it means is something that you do is repeatable. Correct? I don't know how, what do you mean by, what is your definition of idempotent? Something which is repeatable? Or you just know it as a word? Yeah. Now I would like to hear, what do you know about idempotent? Something which repeats, and when you repeat it, you get identical result. I'm sorry?
Something that can be applied multiple times without changing the result.
Correct. Something which can be done again and again without having different result. Correct? Hey guys, come on. When you hear of a term, you should know what that term means, right? See, idempotent, I don't know how you would have studied. In maths, we often give this example that you make some operation happen again and again, and the effect remains the same. Here also, you are seeing idempotency applying. I am doing I equal to 0, I equal to 0, then I am doing I equal to 1, I equal to I plus 1, and I am repeating this ad infinitum. Even if I run it 1 million times, I am sure your imagination knows that I will get 1, 1, 1. I won't get anything else, correct? So that is, right now my function is idempotent. If I run this function any number of times, as many, I can repeat the answer, right? But this is how normal computer science behaves, that we have idempotency. Unless intentionally desired, the effect is not there. This is an example. But what if I were to tell you that there is another way of allocating I? The secret is, how is I allocated? Is I allocated on a stack, which is what is happening right now, so that when the function block finishes, I disappears. That is what is happening right now. I is created on the stack and it disappears. What if I were to tell you that there is a way you could tell the C compiler that this I that I am creating, I don't want it to be perish, I don't want it to perish every time. I don't want it to disappear every time and start again when the next time it is called. I want to give it immortality. I want to give it the law of non-idempotency, right? So that is where the keyword static plays a role. Later I will talk about why do you want to do that. Okay, so let's just understand, suppose I were to declare I as static, what would happen? What would be my consequence? Okay, so let's declare on line 4 static. Okay, now this is, just observe what I would get. I am going to run the same program again. I am not going to change main. I just put a keyword static and just observe now. What do I get? Okay, so now the answer changed. You know why the answer changed? Now I get 1, 2, 3. That means my I, which was initially, first time it started at 0, and then it became 1, then it became 2, then it became 3. That means I didn't die. Yes? The variable I didn't perish. What it normally happens to it, it is not perishing. Now, it is allocated in a separate chunk of memory, which we call static memory, or we call it a literal pool. Anyway, we'll come to literal pool in the next semester, where we'll discuss how literal pools are created, how do they work, what are they. There's a big story there. Let's not venture into that story right now. Just at this stage, just understand that I is created, but it is created for perpetuity, forever. It will not, till the program is alive, your I will be allocated only once, okay, as far as the function is concerned. So, of course, the I in this function and the I in some other function are different, okay. So, if you use I in some other function, this I won't, this is only with respect to this function that this memory is allocated. It is only for the I belonging to my func, okay. So, in the global space of memory, a variable is allocated whose name, let's say, is myfunc underscore I or something like that, which stays forever till myfunc is used. You can do hajar things and again call myfunc. It will continue from the previous value of I. Now, this is good to show, but the immediate question from smart people comes up, why do I need this? Why do I need this? Anyone?
Want other functions to use that variable and it should exist in that function.
No, other functions can use their own I. We are not taking a monopoly on I. They can have their own I and that depends on how they declared it. So we are not grabbing any I. Okay? We are grabbing I for this function alone. But why would I do that? What is its use case? Is just a feature which I want to show to people and admire that feature? Or does it seem to have any utility? Sorry?
We are storing the previous value of I.
Automatically. Yeah. So can you think of where would I need such a thing? I'm sorry? Fibonacci series? No. No. Yeah, go ahead. Somebody said something. Recursion? Okay. You have used an interesting word. How does recursion connect with static? Now there is a relation, but it's nothing to do with recursion. I mean, recursion is also part of the story. See, the argument for using this happens to be, okay, let me take you a little behind and a little different. There is this whole concept in computer science we call stateful and stateless. Okay, it's worthwhile at this point because this concept is important and anyway I will have to explain it at some stage, so might as well do it now. Okay, please listen very carefully. The concept of state. Okay, now every living being or every active agent in the world, I'll repeat this, I'm assuming human beings are active and agents. and living. But the way we look at it in computer science is, every active agent, who is an agent? It may be a program, it may be a person, it may be a caterpillar, it may be anything. Anything which is capable of action is called an agent. In computer science, we call it an agent. An active agent means an agent which is alive, which is not dead. Meaning, if you do something to him, he'll react. That is called an agent. Sometimes an agent reacts to an external stimuli. Sometimes an agent reacts to some internal stimuli also. Any active agent has a state. Now let me elaborate on this. See, you are an active agent. You are in a particular state. For example, at this moment, you didn't have breakfast. That is your state. And you meet somebody on the road who is a little bit nasty. Your reaction will be different. Some other time, you have eaten something, you are well fed, somebody is nasty again on the road, you probably will have a more mutated reaction. You will say, okay, let it be world consist, you will be philosophical, correct? So your state is determining how you react to external stimuli, correct? Every active agent has this state and statelessness. No active agent is stateless. He is always state. That means what? The way this person is going to behave, or the way the agent is going to behave to the same stimuli is going to be different depending on what state that agent is. And in computer science, we make a lot of effort whenever we are modeling human beings or modeling anything. We make a lot of effort to model the state of that being. Because we know that unless we are able to capture that state, we cannot determine what will be the behavior of that person or that agent. It is not just stimuli which determines how that agent is going to behave, but it is the state of the agent plus the stimuli which determines how the outcome is going to be. All of you agree with this? If you look at, remember state and now look at the function. Previously, when I didn't have the word static, my function was stateless. That is, every time it was called, it had the same reaction. It was not predetermined by how many times it was called before, earlier. Every time it was giving 1, 1, 1, 1, 1, correct? It had no state, it had no memory, it had no, it was idempotent, to be very precise. It didn't change. I call it, it will produce 1, very predictable. Now if you see, I have introduced an element of memory in it, a state in it. So now what it is producing is depending on what state it is in. And how did I incorporate state? By creating a variable which has memory in it. So state is all about memory. So when I create something which has memory in it, we call it, it has become stateful. When it has no memory, it is called stateless. Earlier, my func was stateless. Now my func is no longer stateless, it has a state. It knows what is its previous value, and its previous value is determining what its subsequent value is going to be. It is somehow built some kind of a memory. It has become smarter. It knows last time you called me, my value was that much. Now when you ask me the value, I'll give you a different value. Next time you call me, I'll give you a yet different value. It may be just an increment, or it may be some computation of the previous value. The point I'm trying to make is, this function now remembers. Remembering is called statefulness. The act of statefulness or the state of statefulness means I have some memory. I have something in my mind, something which will now determine what I will produce. And that is what is called static. So by introducing the keyword static, even in a language like C, they have thought of it, and they said there is a need sometimes where these functions are my active agents. Sometimes the active agents are stateless most of the time. And somehow, if I want to make my active agent stateful, then I have to create a bunch of variables. Here there is only one, but you could create as many as you want, which are all static. So they determine, so their state determines what I am going to produce. In the previous case, I was idempotent. Everything I know about you, I could tell you, it will produce 1. You call it 1 million times, it will produce 1. Now, it's not so. It is some kind of previous state which is determining what I will produce. If you ask today, close your eyes and say, what does my func produce? You won't know. It will depend on what my func's internal, that static variable value is. That will determine what my next value is going to be. It is not going to be predetermined. It is always going to produce 1. No longer is it true. And I have not done any parameterization or anything. Normally, what they do is, programmers as a habit, now you'll ask, why are you teaching it at the fag end of the course? Reason is very simple. The way we would like you to do stateful behavior is not in this way. We would like you to do it using parameters. So I will pass you a kind of a state in parameters. I would like to take it out of the function. Here, the state has become into the function. And you are not expected to do this. This is not a good programming habit. When we go to object orientation, maybe in the next semester, we will learn this is not a good way of incorporating state. But in C, poor guys, they didn't have the concept of a class. When they have a concept of a class, then we can have state and behavior and all that very nicely. Here, this is an apology of a state, meaning when they didn't have a mechanism to put a state like they have in C++ or Java or Python, where you have the concept of state and behavior being determined by state, very clear, very systematic, very properly written. They say these are state variables, this is the behavior, these are the methods, and it's very nice. So this is a poor man's state, or maybe I should say it the way a language which is incapable of having a proper storage of state does it this way. So a lot of people don't think that static was a very old way of the realization that agents need something to keep their memory, and that should influence what they produce. So this was their attempt. Please understand here, because if you are a student of computer science, you should be a student of evolution also. 50 years ago, also somebody visualized that functions need not be idempotent. And the only mechanism then was parameters. Pass parameters to that function so they'll do something different. But someone else, now I don't know whether it was Dennis Ritchie and Cunningham who did it, or this feature came later. We have to look at history for that. But this was the first attempt at introducing the concept of state. But have you understood what I'm trying to say with the meaning of state, right? It's a very interesting concept and fundamental to computer science. What is also important is it helps us trace that even 50 years ago, now C is almost or more than 50 years ago. So C is now 69, 70, so it's more than 50 years old. Even in those days, there were thinkers who said, no, we need to have a mechanism which remembers things, okay? And C++ came in 89, 20 years later, when they started understanding this much better, okay? So I always say this is a testimony to thinking. They didn't have the constructs like class, but they still had the construct, I could introduce a keyword there, right? Okay. So this is does everyone understand what static means? You can create any number of variables which are static, there's no limitation, and all that. Okay, fine. So we will move on. We don't use this, and I encourage you not to use it, okay? This is just to understand for its historical reasons. And that's why we don't introduce these concepts, and we don't want to use this in programming. Somebody there raised a very nice word, which is recursion. Now, recursion has a very potent recursion. If it is mixed with static, becomes a lethal cocktail. Okay, and I would like you not to mix it. It is very heady and very interesting to go there, but I would say don't go there because it's not a very healthy thing to do. This is one use of static, okay? In the same language C, there is another use of static. Now I'm going to take you to a bit of software engineering and then introduce the second use of static word. Okay, imagine there are two files, file 1.c, file 2.c. These are .c files. Huh? Would that, now this is an important point which you should know. When people develop a project, all of them don't work with one file, right? You are given one file to work with, somebody else is given one file to work with, and then at the end when you have tested each of the file independently or whatever, of course, only one of the file is allowed to have a main, and you may have function 1 in one file, function 2 in another file, and you may have function 3 in another file. See, very often main is there only in one file of the set. There may be more than one files. File 1.c, file 2.c, file 3.c. Like you are developing the main program, driver program. Your friend may be developing these library functions. He may be developing the library functions. Another of your friend, file 3.c, may be developing her own library, which you might use. So she's writing her own code, and which you might want to engage in your main. So in your main you can use F1, you can use F2, you can use F3. They will be with parameters also, it doesn't matter. You can use F5, you can use whatever, right? So this is your main. Now when you compile such a program, you have to compile all of these together. So your command line, because you are using tesslator, you may not be seeing the command line often, but this is a point which you need to understand. When you use GCC, GCC is your GNU compiler, which we are using. When you say run, we are actually engaging the GCC to compile your program and all that. But we are doing it at the back. If you do it at the front, you say GCC file1.c, file2.c. It will take all the three files when you are doing it manually, file3.c, and then you will compile it and you will get an a.out, which is an executable file in C, and then you can run this a.out. Or if you are doing it in Windows, you will get some exe, and that exe can run. Okay. So this is the a.out file. I'll talk about this a little bit in this week also. So a.out will be compiled, and you will compile these three, and they will all become part of one executable. So the executable is only one. If you don't want to call it a.out, by default if you compile it will become an a.out if there is no error. Otherwise you can say -o, small o, and give some name xyz. So this will be the name of your executable which is produced from file1.c, file2.c, file3.c. If you give -o as an option on the compiler. Now there is one very important thing which you need to know. What if I have written file1.c, file2.c, function 1, function 2, file 3 has function 3, F3, F4 and F5. Let's say these functions are using a function. Very often, when you code, now I don't know how much of coding you are doing, but soon you will be doing a lot of coding with us. And when you do a lot of coding, what happens often is, I may be writing 4 or 5 functions, and all the 4 or 5 functions, let's pretend, use one support function called a helper function. For example, all of these functions need data to be in a sorted fashion. So rather than putting the sorted code in every function, what do? You write another function called a helper, which will do the sorting or do something, which is used by F1, F2, F3A. So let's say you are writing a helper function here, some kind of helper, and as normal practice goes, this helper, let's say you have a helper function, it need not be called helper, I am just making it up as I go. So this is a helper function, and F1 uses it, F2 uses it. So I have helper, I am calling helper, and it is part of this file itself. File1.c has a helper function which is used by F1 and F2. Now, when I compile this, similarly, there is an F3 also, and because these people came from the same college, they were told, they borrowed some of the programming habits, that whenever a function needs some support, they also wrote a helper. Okay? So this helper was written for this F3 and it was used helper. This was fine. Okay. Now this is okay. Now as long as file2.c was combined with someone else which didn't have this, okay, as long as it was not combined with file1.c, it was working fine. The moment it combined with file1.c and was compiled together, an error came. Now, do you know what I am talking about? I have file1.c written by you. I have file2.c written by your friend. It also has some good library functions. You also have some good library functions. It so happens, and it's very common to happen if people follow standard programming styles, that both of them, the people who develop file1.c and the person who developed file2.c have a common function called helper, right? Not very rare to happen if you're doing independently, right? So now, when I brought these two files together, because now I need all, because my main now needs some functions from file 2 also, I have a problem. It says unresolved symbol. Unresolved symbol comes for two reasons. There is nothing by that name, or when you have, or it will say redefinition. Sometimes, generally I think it will say redefinition. It will say, when I compile file1.c and file2.c together, it says, oh, I can't compile these two together because you know what? I don't know which helper. There are two helpers. There is one helper in file1.c and there is one helper in file2.c, 1.c and 2.c, right? I don't know which helper to use. The compiler is at a loss. The compiler says, oh, I'm confused, and rightly so, because you never know which helper to use. Now, in order to avoid these problems, there is again the use of static. So what do? So if you don't want this problem to come, you say that each of the helpers which we have defined, okay, you call them, you declare them as static. So you give the keyword here, static, and you give the keyword here as static. So when you give this keyword static and static, what it is telling the compiler is, this definition of helper, this helper should not be allowed to be used outside the boundaries of this file. This helper is also restricted to this file. So when F1, so the outside world, meaning file2.c, its F3 will not get confused with this helper, because this helper definition will not be allowed to percolate here, and this helper definition will not be allowed to percolate here. Okay, so we are kind of creating what in computer science we call them as silos. We call them silos. Silos means what? Isolated containers. Okay, these are called isolated containers, and so each file, the static functions in that are becoming isolated from the static functions with the same name in some other file. So when F1 uses helper, which helper is it referring to? The one in the file1.c. Same thing with F2. When F3 uses the helper, which helper is it referring to? The one in the other file. Are you with me? So if you didn't have these static declarations there, your compiler would never have compiled. It would have said, I am confused. Which helper are you asking me? They are all coming together. So now what we are saying is, by putting the word static before the word helper, we are saying this definition of helper or this scope of this helper is only restricted to this file. The outside world will not be able to see this. Okay. Did you make sense? Do you know why it is needed? Because often it happens that you do multi-file development. What happens is, you develop one file, your teammate develops another file, he has his own library of calls, and they all use an internal helper, and you mess up, right? So this is called localizing the definition of helper to that particular file to avoid mixed language confusion, mixed file confusion, okay? So this is another use of static. Now if you realize the previous use of static and this use of static, they appear different, don't they? The previous one of static was to add state, okay? The second use of static is only to ensure that this definition remains static, remains standing in that particular file, is not available in the next file, and thereby reduces confusion. On the contrary, I hope you understand, if I didn't have a helper in the second file, that static helper or whatever, it would give straight away an error, because it will say this helper which is created in file 1 is not accessible in file 2, so there has to be a helper in file 2, and ideally it should be static. So now, are you clear about the two uses of the word static? Oh yes. When it is used first time inside a function for a variable, it adds state and memory. When it is used like the way I just talked about, it is only to limit the definition of that helper to that particular file, so that the other people can make a same name helper and not worry about, whether I'll have a conflict. This is also called a resolution conflict. Okay. So to remove that conflict, this is another thing which is used for static. Done? Shall we move to the next keyword? This is called one kind of a storage. When it is used like this, it is not a storage class. When it is used inside a function, it becomes part of a storage class. But you should know both. Okay, this can be used for variables also. Okay, let me just, it's a similar usage, but let me just demonstrate it, because I think this is a good point to demonstrate. So this is file 1.c, this is file 2.c, and let's say I have created a global variable here called int x, and then I have written a function here, f1, which uses that x equal to 10. So this is a global variable. So f2 also is a function which uses x equal to x plus 5. Okay. And then I have a main, let's say, which uses f1 and f2. I am not going to get into any usage. Now, if I have here a function f3, okay, and it also has int x for some reason, and x equal to 7. Now, there is bound to be again confusion. Do you agree? Do you agree it is a situation very similar to the previous situation? Only thing, earlier I had a helper function which was causing a problem, which had the same name. Okay. Now, these are common problems. You understand this? Are you able to see the similarity between this and the earlier case? It is very similar. Only thing is, there it was a function. Here it's a variable. Do you know what is happening? When you combine these, when they are independent, no problem. When you combine this, they see 2x as global variable. Yes? No? They see 2x, which are global variable. They say, what the hell? Which x are you talking about? Right? So what would you do? There are two ways out of this. I'll talk about the first way now. So in both cases, okay, what I could do is, this x that I am creating stays in this file. This x that I am creating stays in that file. How would I do that? I would say static. So I would say in this case, static and static. Yes? So this x stays here, this x stays here. This is this x which stays here, this x is this. So when x equal to 7, it is referring to this x. When I say x equal to 10, I am referring to this, and I am referring to this. This is not the static which I demonstrated earlier. This is outside. When it is inside a function, it creates memory. Here it's not memory, it is just scope. That this x, that x which I created with the keyword static now, the other file doesn't see it, or any of the functions in the other file don't see it. It remains restricted and closed in this file, and that x remains restricted and closed in that file. This guy doesn't see that guy doesn't see this. Each is in a silo by itself. So that is called being static, variable static. It's exactly the same thing when we said functions are static. There the function didn't cause confusion. So if you see this kind of error coming, that there is resolution conflict or variable defined multiple times, you should watch. If you are combining many files together, you should watch whether the same variable has been declared global in both and there is no static, and you also know how to solve it. So there is static there. Okay, you have to put the static both places. Are you clear about this? No? Yes? Yes, sir. Are you able to see the difference between this or the similarity between this and helper static? Yes. Same story. Only thing variable, there it was function. Now are you able to see the difference between this use of static and the static which is used for state, maintaining the state, which I demonstrated right in the beginning. Now we move on. We introduce one more type of variable. We have done enough with static. Okay. Now we will talk about another variable called as register. Let's talk about it. Then we'll show you programmatically there is not much to do. It's very simple to use. Int I for I equal to 0, I less than sum is equal to sum I. Okay, let's say you have code like this, very trivial code. What am I doing? Doing nothing much. I'm just adding I to sum 1,000,000 times. Is it 1,000,000? Yeah, it's 1,000,000 times, right? Now, think a little and you will understand what I'm going to say next. Do you all agree with me that I, the variable I, in this piece of code is being used heavily? Shall I say this again? When you see this piece of code, don't you think I am hammering on this I quite a bit? I mean, I am going through it 1,000,000 times. Can you see it getting accessed 1,000,000 times? Everybody knows I am reading I or I am accessing I and incrementing it every time 1,000,000 times. So, can you imagine what's happening behind the scene in this code? I am bringing I from memory, adding it to this variable sum, putting it back. Why am I putting it back at the end of the loop? Because I is incrementing. Then again bringing I from the RAM. Imagine there is RAM, there is CPU. CPU consists of ALU. See what is happening. Just think in your mind. I can draw the picture, but you can abstract also. There is this RAM in which I is sitting. I am getting I, adding it to the variable sum. Actually, I am getting sum also, but let's keep that aside. I am getting sum from memory, I from memory, adding it and putting it back in sum first time. Next time, and I am at that time also incrementing I. Just imagine what is happening. Okay, in this loop, what is happening? First, I get I from the memory every time, and then I add whatever is there in I to sum. Yes. Then after that, I do two things. I keep the sum back in memory. Yes. And I keep I with an increment back in memory. So this is happening 1,000,000 times. You are with me? This is happening 1,000,000 times. And I am perturbed. I am agitated. Oh, 1,000,000 times I have to go to the memory, get I. 1,000,000 times I have to get sum, add them, put them back, sum and I 1,000,000 times. Why should I have to go to the RAM 1,000,000 times, get I, get sum a million times from memory and do this operation again back to million accesses. Yes? Can I not make this better? So, in a CPU, there is always a bunch of registers, so there is RAM. Okay, let me draw the picture. I'm sure you have seen this picture in school also. CPU, there is RAM. In the RAM, sum is sitting, I is sitting, and every time what is happening, I'll try to write this in simple words. Fetch sum. Fetch sum means fetch sum from the RAM into the CPU. Rather, into the CPU has a unit called accumulator where all the computations get done. Fetch sum into the accumulator. Yes. Then fetch I into one of the registers in the accumulator because accumulator is full. Then add I, that is add this value of I to the accumulator. When you say add I, it means add the value of I to the value sitting in the accumulator. Add I, this has low level machine instructions. I am writing the mnemonics for it, but at low level it will be machine instructions. Add I, then add I to sum, store sum, increment I, store I. And this whole thing repeats a million times, right? Can you see this happening in this code? What I just wrote, I wrote a loop. But can you see this happening? See this happening. Sum from RAM, that is the RAM, into accumulator, fetching I from the RAM into the accumulator, into some register, and then adding that I to the sum, I am abstracting it, then putting the sum back, incrementing I because I is equal to I plus 1, and then doing it back I. So, when a computer science engineer will look at it, he will say, this looks bad, correct? It's wasting too much time. I need to optimize it. What is the problem here? The problem is not in the addition. That our CPUs or our accumulators do it in a jiffy. They don't take time. Problem is not in the add. Where is the problem? Does fetch sum, fetch I, store sum, incrementing also is not slow. Incrementing is cut, it increments in the accumulator. The 4 instructions which really slow me down are fetch sum, fetch I, store sum, store I. Correct? Can I not improvise on this? Can I not improve on this? Now how the hell do I improve on this? Well, that is where you have a concept called, now I'll rewrite the code. Okay? We'll go back to the code, the previous page. Now, I'll improve this. This is the non-computer science way. Okay? A computer science engineer, especially when he sees this, if he sees 100 here or a 20 here, he doesn't bother. 20 won't bother. The eye or the ear or the mind does not feel very upset. But when it sees million, opportunity, right? So when it sees this, what I'll do is, I'll use the keyword register. Register. What am I doing? I am now making a request. Underline the word request. I am making a request to the compiler. Hey compiler, great man. Okay. You are my friend. Okay. Why don't you, for this sum and for this I, can you not, instead of all the time asking me to go to RAM and get it, can you not allocate some 2 small registers in your CPU? Remember, You have to request the compiler, you have to implore the compiler, because compiler has only a limited number of registers and it may be using them for its own use. Please, can you help me? These two variables, sum and I, can you put them, give me two registers in your CPU? You allocate two registers permanently. Permanently means till this loop is going on. Put this sum and put this I in those two registers, and I will then use them, because I seem to be using a whole lot of them a lot of the time. So just put them in your registers. If I put them in the registers, then what is the advantage? Advantage is I no longer have to fetch them from the RAM. I don't have to store them back to RAM. So every time I want sum, I can get it from R1. So it becomes move sum or move R1 to accumulator. So this instruction of fetching sum becomes a move instruction. This instruction of fetching I becomes a move instruction. Move from the register to the accumulator. This some register gets allocated for it. Let's say R3. Some register gets allocated for it, R4. In fact, if it is already there, then I don't need to even use it. So R3, so every time I don't have to say fetch sum into the accumulator, I have to do a move R3 into the accumulator. Now this is part of the CPU. This is not outside the CPU. This is not in RAM. So if this fetch was taking 1,000 or let's say even 10,000 units of time, this instruction would take just 1 unit of time. I mean, moving sum from the RAM to the accumulator as against moving sum which is in a register, which I have asked it to be stored in a register, to the accumulator will take 1 unit of time. So, and the same way while storing, I don't have to send it back to RAM, I can just move it back to this R3 or whatever register I have given it to it. I have to move it back to R3. This increment I have to perform in some register R4, and I don't have to store it anywhere because it's already in a register. So this way, do you understand the difference between this and the earlier code? This way, I have become sensitive to the point that I am using it regularly. So rather than asking the system to go all the way to the RAM, get it every time, I am saying keep it in a register if you can, because I am using it frequently. Now, where is the glitch? The glitch is, it's not called good habit to ask for register variables unnecessarily. Just because you know that there is something called register, you should not use it. Because what will happen is, the compiler will give it and it reduces the availability of the registers to the compiler. So it codes becomes less optimized. Second, it is like saying, I am going to use a fast lane. There are some jerks which you see all the time. They don't allow the other guy also to go fast. This is what happens if you act like a jerk. The variable, you should choose to make it register only if it is used like this, where it is used repeatedly long time. Unnecessarily don't ask your compiler to sacrifice its registers for something which is not needed. You have to determine. So our skill lies in determining whether it is needed or not, and then saying I want it as a register. Again, at this stage, let me be very careful. Just because you ask for register does not mean the compiler is going to obey you and give you a variable in the register, allocate a register for this variable. The compiler may say, go to hell, there are many people like you, or I just don't have enough registers at the moment when I am compiling. I don't have enough registers, so I can't give you registers. So it's only a request. It is merely a suggestion. It is not a demand, and it may be fulfilled, it may not be fulfilled. If the compiler has that many registers to spare, it may give you it. If it doesn't, it will say no, we'll run the code without register. So register is always a request, has to be done very carefully. Don't unnecessarily do it. Unless you see that variable used very often, don't unnecessarily utilize it. Okay? So that is what is called the utility and use of a register variable. So we have learned two different kinds of variables. One is called static, the other is called register. Is everyone clear when do we need register? No, yes. I have tried to explain, some of you may have understood, some of you have not, but it is when a variable is used repeatedly in a loop. Normally you should see a loop and you should see a big loop. If a loop of 100 or 200 or 500 or even 1000 doesn't qualify for a register. Also it depends on what you are doing in the loop. Okay? So if it is going to slow you down a lot, then only request for register. Okay, so this is the second kind of variable. We have seen static, we see register. Now there is one third kind of variable which we use. How do you use register? Well, I just showed you. If you want to see this code, go to the code. Yeah. Not here, but you just use the word register, English register. Okay. Maybe you should just use it. This loop doesn't guarantee, there is no loop. But just to show you the syntax, just show, remove 4, static there. And just say register. This is just to know that you know the spelling of register. This is not a correct use, it's used only. Are you with me? It's not even looping on that I. So this is a wrong use, but how to use it is this. Is it clear? It's appearing with the correct syntax, correct color. So this is register. Okay. Give me a register for this variable. Give me a CPU register, don't put it in the RAM. That is in simple words what it means. Okay. Now going forward, now we talk about the third variable. After that, the fourth you already know. So third is called extern. Okay. Now this is actually in some way reverse of static, but let me elaborate. Okay, now I go back to the f1.c, or let me call it file1.c as I did earlier, file1.c, file2.c. Now I say int x and I say f1 some function, I say x equal to 10, I again say int x and say f2 and x equal to 15. Now if I combine these two, what will happen? Will it compile? If I compile these two together, will it compile? No, yes, no. Because it will say there are two x which are global and you seem to be using x in f2 and you seem to be using x in f1 and I don't know which x, when they are combined together, I really don't know which x they are going to talk about. I am confused. So one way is, we talked about, both we make them static, yes, then the compiler feels happy and it says the x in f1 is the x which is created in file 1, the x in f2 is the x which was created in file 2. But what if your requirement was something else? So what was your requirement? You wanted only one x. Yes? You didn't want two x's. When you declare static, you have two x's, one for this guy, one for this guy. No, yes. But what if, and if you don't say anything, they will collide and the compiler will say, hey, you've gone bonkers or what, right? So, but what if your requirement was, you wanted x to be created only once, you are with me? And you want it to be used in both the files. Happens often when you have an array, it's created in one file and file 2's functions also need it. Okay? So in that case, what is the word you will use? Okay. you will say here, in file 2, you will say extern. In file 2, you will say extern, and in file 1, you will say int. So what are you telling the compiler? Look, I am using an x, but you know what? My x is going to be defined in some other file. I am not, so this file cannot be used by itself. Are you with me? Because it doesn't have its own x. It is telling the compiler, the x that I need is not coming from me. It's an x which is coming from some other file. It's an external x. It is not an internal x. The x that I am using in this file, I have declared it and it's coming from somewhere else. So then my program, this will compile independently, this will compile, and they'll compile together. But every extern, you can't say extern here and extern here. It is like saying, I want an external x, file 1 says, file 2 also says I want an external x. From who? At least one file in the combination must have this, the others can say extern. Are you with me? No, I don't know whether you understood or not. I want the x to be shared across these two files, so I can't say just int x, that will result in confusion because which x? So I have to say that this file is saying an extern, so this file is saying so then when you do this, the x equal to 15 is this x, the x equal to 10 is also this x. This file is indicating to the world, I am dependent upon an x which has to come from somewhere else, which has to come externally to me. It is not internally available to me, it is available externally to me. So that is the keyword extern and the circumstances under which this is used. So when we say extern int x, it is indicating that I don't have an x, I need to be used with a file which has an x, use it with me, use that x. And when I declare x equal to 10 or 15, it refers to this x. So how many x are allocated? Just one, no two. Each x is different. Each x is same. So this x is this, it's allocated only here and this guy is using it. Are you understanding the difference between this and marking it as both static? Static means this guy has his own x, this guy has his own x. Okay? That is static. If I say extern, it means I don't have my own x. I am dependent on x somewhere else. This guy needs to supply me that x and I am going to use that x. Okay. This is also done very often. Okay. Now, these were all things which actually in the original C they were not envisaged. They were kind of added subsequently as people realized. See, for example, register came in when you wanted to optimize the performance. Extern came in when they all wanted to use the same variable, create it only once. Static came in when this x had to be different from that x. All these came through use. And all of these, when people started realizing, oh, this is becoming a mess. So somebody reading this code looks at this kind of code and says, oh my God, that means what x I am getting is somewhere else. It's getting manipulated by someone else, and all of that problems are happening. So basically, this thing all led to the principles of object-oriented programming. And principles and problems that we saw in object-oriented programming now led to languages like JavaScript, Python, which have more of functional programming in it. It's a kind of evolution which today all of you should know, and that is why we are a little upset with the fact that people are insisting that we should add C. Actually C deserves to be dropped only on the merit of this, because it's not evolved language, it's old language. How much can you evolve? It is like you have an old horse, you can make it wear a nice saddle, but an old horse is an old horse only. A conceptually old language, a conceptually jaded language, a conceptually tired language. You're trying to somehow put steroids in it and trying to boost it to move forward, but that's not the way it should happen, isn't it? You need new languages, because When people start working with languages, they realize there is so many limitations, and then they evolve. Then the new language created tries to overcome the problems of this. This becomes messy. All this is nice to talk about, extern, register. Can't the compiler take care of it on its own? The smart way of saying it is, this register thing, why do I need to say that? Can't the compiler be smart and realize that it's a loop and allocate I in the register itself? Correct? Why do I need to say that? Is it not seeing that there is a loop of 1,000,000? And doesn't it understand that when there is a loop of 1,000,000, there is going to be so much of RAM access? Can't it figure out on its own that memory allocation, be in a register? Why does it need my support? And why should I waste my time, my energy, deciding to call it register or this or that? Why can't it go figure out on its own? That's the modern way of thinking. And modern compilers do that. In Python, they don't ask you to say something is registered, right? They don't. In Java, they don't have. They have in Java to a certain extent, but anyway, it's a relic of old. Python, they don't ask. JavaScript, they don't ask. The compiler is smart enough to figure it out. Yes, I need it so many times, so I will automatically allocate it to register memory and not ask you to do that, right? But here, it asks you. You says, what? Okay. Anyway, so these are, what is the fourth type of variable? So we talked about static, we talked about register, we talked about extern, and the fourth type of variable is what is called a local variable, which you already know. The variable which is created in a block and it dies in a block, that you already know. That is the fourth type of variable. Some people call it an automatic variable. So in C they have a word called auto, but that's superfluous. You don't need that. Okay, so I think stop here.